Right guys, okay, good. So, for the Unit 2 work, for the redox work, you've done some oxidation states, you've made an overall equation. I want you to use these skills now. For the rest of it, check it with the mark scheme, come and find me if you need to go over things. I want you to try this much harder question, slightly harder question, not much harder. Question 3 here. I'm just going to introduce it to you. I'm not going to do any of it, I'm just going to introduce and let you know what they're looking for. Okay, so here we are. 3 different processes have been used to extract bromine from potassium bromide. Okay, so every one of these equations, they're going to ask you to make up these equations later. Every one of them is going to have potassium bromide on the left-hand side, KBr on the left-hand side, and it's going to make Br2 somehow. Okay, so you need to make up your equations from that. First of all, make the half equations, then make it into a full equation, but you know that's going to be one of the processes there. You're going to have Br minus going to Br2, it's going up in oxidation state, so you're going to have that oxidation happening, so something else is going to be the oxidizing agent, so itself is going to get reduced. Okay, so your sulfuric acid is going to get reduced in extraction process 2. A hint that sulfuric acid will reduce to SO2 gas, okay, so sulfur dioxide. Okay, that is a reduction, so look at that, make up a half equation for that, put it with your half equation for Br minus. Remember, half equations, you should always just use the ions, don't worry. This K plus here, this K plus here is also a K plus here. It hasn't changed at all, so you can simplify things by not putting that in the equation. Okay, just a little hint there. This one, potassium bromide with chlorine gas. We know again we're going to make bromine, so it must be the chlorine that gets reduced. What's chlorine going to get reduced to? It makes sense that it just gets reduced to chloride. Okay, have a go with that. Write the half equations, then write the full equation. But obviously that's what you're going to do later. Look at the question first. So for the question first, part A, half equation for conversion of MnO2 into Mn2 plus ions. Okay, so MnO2 into Mn2 plus ions, part of the aqueous solution, SO4. So half equation, state what is made by the term oxidizing agent, something else that gets reduced, and identify the oxidizing agent in the overall reaction. So look at the thing that's getting reduced, that's taking away the electrons from the thing that's getting oxidized. Okay. Now part B is the more meaty section. Let's go all the way down to it. So here's a lot of marks in one time, so you've got to be well structured with this. 5 marks here. Write an equation for 2, an equation for 3, percentage atom economy for 3, suggest why extraction process 3 is the method in large scale used today. So there's 4 different questions there. One of them must give you the possibility for the 5th mark, okay? But make sure you answer every one of those 4 questions there when you do it. Have a check with the mark scheme, but have a full go first. Okay? Good. So anyway, I hope you enjoyed that episode of I Love Chemistry with me, Dr. Winchester, and I'll join you for next time.